Corporate finance practice problem using OneNote. We will calculate the principal as a percent of bond price. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're in the tab on the left-hand side. We're in the practice problems area, and then in the 1014 principal as a percent of bond price tab. Also note that if using OneNote, you might want to take a look at the immersive reader. Many of our presentations will be mirrored down here in the text files, having the same numbers in the text files. The text files then having transcripts that can be translated into multiple different languages and either listened to or read in multiple different languages, thereby being a good complement to the presentations. Closing up the tab up at the top, we're going to have our information up top. We'll work through that information down below in the blue areas below. Like with prior problems, we will work through a lot of the components and sections of the practice problem a few different ways as we consider how to calculate the present value calculations related to them. Information then, we have the bonds outstanding. Par value is going to be the 1,000. The percent, 17%, matures in 30 years. This information up top can be the information we can consider to be basically actually on the bond or something we could derive from the bond itself, as opposed to the price that we would have to get basically on the market side. We have here the percent. So we're going to be picking up the market percent. This would be something not on the bond, using that then to determine what might be the market price. We will then do a similar calculation we have seen in the past to get to the market price, meaning we're going to have to take the present value of the annuity and the present value of the principal up top, and then we'll do a comparison to kind of think about what will be the weighting of those two components for the price, meaning how much of the price is comprised of the principal that's going to be paid at the end, in this case the 1,000, and the interest payments, the annuity payments, as time passes. Once you think about this relationship of the price, the value of the bonds, then you can think about how that would change as, for example, the rate on the bond changes, the rate for the market changes, the number of years change as we get closer, for example, to the point of maturity. So we're going to go through this process. Note also that the market rate is less than the rate on the bond. So if we think of this from the standpoint of us issuing the bonds, we kind of have an advantage, right? We're saying, hey, look, we're issuing this bond. We're trying to sell it and get money. Note, you're not going to find a better bond anywhere else because the market's like 15%. We're paying 17% if you buy this bond. Therefore, we're not going to be selling it most likely for the 1,000. We expect the price then to be higher than the 1,000. So expecting that, now we'll calculate the price. Next question, of course, well, what exactly is the price? We got to do the present value calculations to do that. Present value calculations then for the annuity will be the 1,000 times the 17%. That's the amount of payments we'll get periodically, in this case yearly, for 30 years. Then the present value of 1, basically the principal that will be happening at the end of this process at the end of the 30 years, that being the 1,000, present value of 1 calculation for it. So first, the present value of the annuity. We have our formula up top. It's going to be P times 1 minus 1 plus R to the negative N over R. P is going to be the 1,000 times the 17%. That's the amount of payments that we expect to be happening periodically, in this case yearly, for 30 periods or 30 years. Then the numerator, 1 minus 1 plus R. R then is going to be the market rate, 15%. And then to the negative N, that's going to be the 30 periods, over R, once again, market rate, the 15. Let's go on down and break this out into our table. We're going to put this in a table format. P on the outside, that's going to be then calculated at the 1,000 times the rate on the bond, the 170. So there's the 170. Then we got the 1, which is part of the numerator. Then the 1 plus R to the N. We're going to pull that into the inside of our table, 1 plus R. And we're going to add those up, 1 plus 15%, 15% being the market rate gives us 115%. Taking that to the number of periods, negative number of periods, in this case years, that being 30 of them. 115% to the power of 30 is 0.0151, and so on. Let's do that with a calculator. I'll recalculate that. Note that if you are doing this in a test situation, you do need a calculator that takes the power of. So I'm going to select the hamburger on our calculator in Windows, scientific calculator. I'm going to recalculate this. We want the 1 plus the 0.15 or 15% gives us 1.15 or 115% to the power of, which is the x to the y, caret, in other words, up top, 30 periods. We need to make that negative, so I type the 30 first, then I hit this little negative item down here to the power of negative 30. It's going to give us then that 0.0151 and so on and so forth. So I'm going to go back to my normal calculator here, the standard calculator, make it a little bit smaller. Then we're going to have the 1 minus that number we just came to. So we got 1 minus the 0.01510305 gives us the 0.98489 and so on. That's the numerator. Then we'll take the denominator, which is going to be the rate or 15%, same market rate there. Taking this divided by 0.15 or 15%, making my calculator a little bit larger so I can see the answer. And that then is going to be that 6.56597 and so on. Then we can take that and multiply it times the 170. That gives us our 1116.22. So that then is going to be our the present value of the annuity. Now let's take a look at the present value next time of the 1,000. But before we do, we're going to get to this number a few different ways. One way is that we can think of this as present value of 1 calculations, 30 of them. I can break, in other words, the annuity out into present value of 1 calculations, bringing each payment down to a present value of 1, something difficult to do with a calculator, easy to do with Excel, and can be quite illuminating in terms of what is actually happening. So if I take this first payment, for example, the first payment of the 1,000 times 17 or 170, that's the first annuity payment, and we present value it. I won't do the math here. You can do that in Excel. We do this in Excel if you want to look at the functions. But conceptually, the 170 would be 1 period back, 148. If we did this for the second period, we'd have another 170. We would need to bring it back 2 periods, this time that being the 129. The 129 plus the 148 would be the 276. The third period then, we have another payment of 170. If we brought that back 3 periods, that would be 112. 112 plus 276 gives us the 388. If we took the third or fourth period here, 170, bringing that back 4 periods now, $97 would be the present value, plus the 388 would give us the 485, and so on. These numbers are rounded, pennies have been removed. Going all the way down to the bottom, 30 payments, we get to the 1116 once again. That then, same result we got mathematically, although we added the pennies here, no pennies on this calculation. Also note that you could then do the same conceptual concept, which we'll do later, which is then to tack on the present value of the 1,000 that would happen at the end of the process. Present value of 1, the principal, in other words, bringing that all the way back would be $15 present valued, plus the 1116, we get the 1131. This then, without the pennies, would be the price that we would be considering here, given the assumptions that we have. So this is one way we can calculate it. We could just present value using 1 the whole way through and not do an annuity at all. But we'll do this another couple different ways. So now let's do this payment one more time, the annuity portion, the 1116 about estimated, with the tables now and with the Excel functions. Excel functions here. So the Excel function would look something like this. This would be the easy way to do it, similar to a financial calculator. It might be even more popular than the financial calculator these days because you can get Excel basically on your phone or Google Sheets or some spreadsheet. So this is going to be the present value of the rate. The rate would be the market rate, the 15%. The number of periods would be 30 periods. And then the payment then is going to be the 1,000 times the 17, or in other words, that 170. Just selecting that into your function, that'll give us the 1116.22, again, the annuity portion of our price. So finally, we could do this with the tables. We're looking tables, 15%, 30 periods, 15 and 30. So there's the 15, 30 periods is down, way down here, right there, 6.5660. So there's the 6.5660. The 170 times the 6.5660 gives us the 1,116.22. That then same as what we got up top. Now let's go on down and do the second part, which is going to be the present value of the 1,000 basically the principal that would be received or paid, depending on what side of the transaction you are on, at the end of the bond, which would be, in this case, 30 years, 30 periods. So we'll do the present value of 1 calculation, which looks like this. It'd be the future value. I can think of it as over 1 plus r to the n. Future value is going to be the 1,000 this time. 1 plus r. R is going to be that 15% market rate to the number of periods. In this case, 30 periods, 30 years. Putting that into our table format, we then have the 1,000 outer column, that being the num or numerator. And then we have the 1 plus r to the n, 1 plus r to the n. There's the 1. There's the r, which is 15%. So 100 plus 15, or 1 plus 0.15 gives us 1.15, or 115%. And then we got to take that to the power of 30. That's the number of periods. So 115%, or 1.15 caret, or to the power of 30, then giving us this 66.211772. Then we can take the num over to the the numerator over the denominator, and that would give us the 15.10. If we add that to what we got, that's the present value of the 1, the principal payment, to the present value of the annuity we got last time, the 1116.22, you'll recall, then we get the price, 1131.32. Scrolling back up to that yellow area that we did last time, there's the 1131, no pennies, same calculation that we got here. That then being the price. That's the price. So that's the price. Note that it's higher than the 1,000, and we totally knew that it would be. We discussed that like before we started this whole thing. That's because the present yield or the market rate is below the rate on the bond. So the person selling is going to be having kind of an advantage there, saying, hey, look, you're not going to find a bond that is like our bond, where we're going to pay 17%. You only get 15% elsewhere. Therefore, we're going to sell it for something greater than the par value, greater than the face amount, and that greater amount then being the 1,131.32. Now, note that this price has 2 components to it. It has the component of the annuity, which is by far the bigger amount here, and it has the component of the present value of the principal, the 1,000. So now we can do a comparison. We could say, well, what is the ratio of this price? How much is the price of the principal compared to the price of the annuity portion of it? And then you can think about how this would change as time passes and things change, right? So in other words, this relationship, if, for example, we had differences in, for example, the percent that was being paid here, you would think that if this amount was less, then the annuity portion would be less. You would think that you would have less in terms of the value, of course, of the annuity, because you'd be getting paid less per payment on the annuity side of things. If the maturity date was less, we have less of a maturity date, you would think we would have less annuity payments then, of course, because you would have less years, even though those annuity payments are smaller as you get out into the future, the later payments. And you would think in that situation that the 1,000, once you get closer to the payment of the 1,000 no longer will be worth only 15.10, but once you get closer to the maturity date, whether that be shorter bonds that are issued or as time passes with this long bond, then you would think that this amount would be worth more because you'd be closer to that date, and if you present valued it, you'd be closer. And then if we had a difference in the present value or the market rate, that also you could think about how the market rate would have an impact on both components, the present value of 1 and the present value of the annuity, as we do the present value calculations. So let's think about then, we'll get down to that kind of comparison down here, but before we do, let's first do the present value of 1 calculation. If you looked at it with Excel, it would be the rate. The rate would be the 15%. Number of periods would then be the 30 periods, comma, because it's now future present value of not an annuity, but 1. Future value then being the 1,000. That gives you your 1510 again for the present value of that 1,000, bringing it back 30 periods to the current day. Table time, let's do it with the tables. 1,000. The tables we're looking at 15%, 15 and 30, but this time with the present value of 1 tables. So 15 and 30, and the tables aren't here. The tables have disappeared, but I won't find the table. We'll leave the table away, but it would be 0.0151. That would give us that 1510 again. So then let's do the new thing down here, which is going to be the principal as a percentage of price. So now we're taking the 15.10, the principal, meaning the 1,000 that has been present valued is now worth the 15.1. And then the price we calculated to be the 1,131.32. So that means the principal at this point is only 1.33% of the price, which kind of makes sense because this is, you can see that this is basically a fairly long bond, 30 periods out. And so when I present value this 1,000 back, when we present value that back, it's a fairly small amount of the principal, and the annuity payments are 30 payments at that 17%. Note that as time passes, then this principal portion will become more relevant because as you present value this closer to the end result, it's going to be a bigger number. And the annuities then, the annuity payments, there'll be less of the annuity payments. So you'd think, this ratio would be going higher, most likely, basically as time passes. And so you can kind of consider different situations when you're thinking about the price. You can think about, well, what is the weighting? We have the price now. What is the weighting between the amount of the principal payments and the amount of the interest payments?